At the heart of modern IT sits public key infrastructure, or PKI. Every time a server proves its identity, whether to a human or another machine, every time a device connects securely, every time software verifies a trusted source, it relies on a digital certificate. That certificate has a defined lifespan. When it expires, it's like a passport that's no longer valid. No renewal, no trust. Here's the thing. Given the rising software complexity in safety-critical industries, this is rapidly becoming a human life-critical problem. An expired certificate deep within a modern car today, while it won't immediately compromise the safety of that vehicle, it could still have other security repercussions later. In the enterprise, certificates aren't just used for websites. They secure APIs, they authenticate devices, they protect internal traffic, sign code, enable VPNs, and encrypt machine-to-machine communication. Large organizations manage tens or even hundreds of thousands of certificates every day. Missing just one can halt production lines, interrupt logistic systems, or prevent critical updates from deploying. And here's the key point. Certificate expiration, it's not a cyber attack. It's an operational failure, but the impact can look exactly like one. In a world where everything talks to everything else, trust is automated. And automated trust, it has deadlines. Managing those deadlines, it isn't optional. It's fundamental to keeping the modern enterprise running. And now, ICS as well. This is a story about digital certificate trust issues that extend across the supply chains and even supply chains for critical infrastructure. I'm Robert Vamosi. This is Error Code.
So I am David Sequino. I am the co-founder and CEO of OmniTrust, formerly known as Integrity Security Services. We did a management buyout of an embedded software company that did mission critical solutions for aerospace and defense for 45 years, and our growth was outpacing theirs. And we decided to go out on our own, so we did a management buyout in 2024.
So we're going to be talking about security in the hardware and software supply chains. And we're going to be talking about digital certificates that often get neglected across all the many components found in, say, airplanes or automobiles.
The bright line differentiator for us and why we're really unique, why we're rebranding the company is we started with the hard stuff in OT, IoT, safety critical type applications, right? Security where it matters most effectively, right? High assurance. So automotive, high assurance, aerospace and defense, high assurance, critical infrastructure, high assurance, medical devices, high insurance, basically regulated verticals that need a white glove approach to delivering a solution that always works, that won't take your supply chain down, that's highly secure, right? And in doing that, we met sort of this enterprise side of the house that, our DLM platform, which is our IoT PKI platform, DLM Trust, and we have DLM Update. That is a point-to-point encrypted network across your supply chain. So you have a head end, and then you have a bunch of endpoints. And whatever you put in the head end, you're guaranteeing it gets to all the endpoints. Well, between that, you have a firewall, switch, router, hub, firewall. And we found out that there were all these certificates that were being issued off of a Microsoft PKI or something else. And every time those certs expired, the network would go down. But because we were a mission critical supply chain platform, they're like, your system's terrible. You just took our supply chain down. And I go, I bet you 25 cents I didn't take your supply chain down. So we ended up being the network engineers that found all these expired certs, and I gave up. And I said, you know what? We're going to get into certificate lifecycle management, and we're going to do an enterprise PKI and a certificate lifecycle management platform because clearly no one's doing it well.
So let's talk about automobiles. For example, in automotive, in the analog world, OEMs have always been really good about defining all of their supply chain parts. They needed to know when a brake pad failed, when it was manufactured, who manufactured it, and where it entered the supply chain process so they can do a recall of a specific make and model of their vehicles. That's a decade-old safety critical thing. And I find that with software, that hasn't always been the case. In the automotive industry, there was this rush to get into software. And now our vehicles are largely defined by software. Yet the pedigree of that software, that's not so well documented.
Absolutely. Yeah, we pick the automotive industry for business reasons, but also because, we're tackling the hardest problems. And as you know, there's, 30 or 40 true OEMs in the world, if you count cars plus tractors plus all sorts of other vehicles. And as you said, the supply chain is highly complicated even before there was software. And a car, when you had a 1969 Mercury Cougar, there was zero software in it. And now we're, pushing 2, 3, 4 million lines of software in every vehicle. So you've got, embedded 32-bit, 64-bit processors. You've got AI processors now for, data fusion to create, level 4 automated driving. And so, the problem is used to be sort of one axis, right? I got a hardware supplier, no software, but now the axis is multiplied, 2 or 3-fold. It's a very three-dimensional problem where you've got hardware, you've got, complicated CPUs and many, many silicon chips, and you've got this massive software issue. And, they're seeing it as a beneficial thing where you can go from 65 ECUs in a vehicle to 20 or 30 and use the software to define what the function is. So, historically you might have a braking, steering, engine controller, body controller. Now they want to move to these zonal controllers where the software is defining the function. But there is massive problems with that because many of those software functions that they're driving are safety critical, meaning they are focused on motion, right? So steering and braking in particular, right? But if you've got, an in-vehicle infotainment center, right, the spinning graphics for the music or whatever you're doing in the vehicle, that's not safety critical, but your backup camera is safety critical. Or if that's absorbing information from LiDAR or cameras all over the vehicle, that's also safety critical. So, OmniTrust is here to ensure that every single piece of software on all of those devices, those ECUs, is authentic and from a known good source, right? And you're doing secure updates because a big part of software defined is being able to update the vehicle after it's shipped off the manufacturing line.
So I want to differentiate and be clear here. This also applies to firmware as well.
Yes. So think of every device in a vehicle, right? And for that matter, every IoT device as an onion that you cut in half. And you have all these concentric circles. At the center of the onion is a secure location in a silicon in a CPU to protect a secret. Then from that secret, you're going to authenticate the secure boot. Then you're going to authenticate the operating system if the device has an operating system. Then you've got a bunch of applications. Then you have a bunch of data. If any layer of that onion has not been authenticated to an immutable root of trust in a piece of silicon, you're not secure. We authenticate every layer of software and we sign that software exactly the way the CPU wants to do it. And the difference between the enterprise and the OT network or safety critical IoT networks is that there are hundreds of CPUs that tier ones use in all the different ECUs. And not every chip does authentication the same. So our DLM Trust platform has a very unique capability of doing this code signing exactly the way the chip wants to see it. And if you don't do it the way the chip wants to see it, it's not secure.
So you've got these suppliers who are providing chips that are used in an automobile. You don't necessarily have the visibility into every single firmware that's entering this process. Is the solution to provide an overlay or some sort of intermediary between the original chip and the function it's performing within the vehicle?
We do have visibility. So the way an engagement works is, you have a big OEM that comes to us, right? And they say, listen, we have this problem. We own the liability. We own the fact that if there's a recall, we're paying for it. Yet we have 100 tier one providers. They're shipping us X number of ECUs each. Every one of those ECUs has a different CPU in it. And we need to ensure every layer of the onion is authentic. Here are all the ECUs we're putting in this model. Here are all the pieces of software we want you to authenticate. Help us with that. So then we get the reference boards, and we have a huge board farm of every embedded board on the planet. And we basically turn these software images into DLM-Trust services. So it becomes a point and click environment, or more importantly, it becomes an API that the customer just calls in their build environment and says, sign this, this firmware image, sign this OS image, sign this app, sign this Cal data image if it's a transportation control or a transmission controller. So we do have visibility, and it's their choice. We can go as granular as they want.
So for those chips that don't have these trusts, is there a way to provide that?
In some cases we can. There's a lot of old CPUs that don't have good security. So we can create, better security than no security, not as good as if the chip has an HSM in it, hardware security module engine in it.
So we've talked a lot about automotive. Are there other critical infrastructures? For example, aerospace. Do they do something similar within aerospace?
Yeah, it's interesting. So Green Hills Software, our previous parent company, they had been in this business. They founded the company in 1982. They have an EAL 6+ certified operating system called Integrity. They're in 100 flight critical applications, and what the common criteria EAL 6+ certification means is that you can run applications on one OS, and those applications can be separate, and they're as good as an air gap. Now, that's wonderful. The aerospace and defense market uses it for, if you're going to run software in something that flies, there's a DO 178 certification. And in that world, they understand safety critical. They don't understand security. And it's a hard industry to crack into. And I brought the business to Green Hills in 2010 thinking, oh, they've got all these applications in aerospace and defense. I will build my DLM-Trust and my DLM update platform for this vertical, and everybody will want it. Well, it was like 8 years, and we won all this business in every other industry except for aerospace and defense, because they always believe that guys with guns, tall fences, PIV cards. I've known this guy for 40 years. They've worked at Lockheed, Northrop, Raytheon, whatever the company is. We know how to do this, right? They were actually doing no security. And then about 5 years ago, it blew up. And there are all these new standards that basically say, whether it's an airing standard or a DO 326A, right? Very similar to the auto industry. They're like, we need to authenticate every layer of the onion. We need to know the traceability of our supply chain. We need to sign every line of code in our device, right? They have anti-tamper issues too. So if it's some sort of vehicle that is a one-way vehicle or a round-trip vehicle, if they lose the vehicle in a combat zone, they want to know their flight software is safe, meaning it can't be pulled out and taken. So there's massive IP issues in that market. So that's one of our fastest growing markets, and the aerospace and defense needs us everywhere. So we have very specific solutions for them. We have a DD 256, which is a facility clearance. We have, top secret and secret cleared people to work on these programs. So it's an exciting market, and for me, it gives me solace as a taxpayer to know that many of these program offices are now rolling these cyber requirements down to the prime contractors because we need it desperately. This is mission critical. The world is not getting safer. It's getting scarier by the day.
I want to expand a little bit on the difference between safety critical and security, and the fact that at the enterprise level, that nuance is often missing.
So I break the world into, a classic Venn diagram where you've got reliability, safety, and security, right? And there was a time when there were three bubbles, as your question is teasing out. Those bubbles are completely on top of each other 100% now. So there's one circle, and you can't have reliability or safety without security. That's really what it comes down to. And to more directly answer your question, the challenge people have is in and it was funny, my old parent company, Green Hills, they would always call themselves a security company. And I was like, you're a safety critical company, right? You know that this application is going to run on your your operating system, and it's not going to affect the application right next to it or the application next to that because of your separation kernel, right? That is classic safety critical. That means that if there's something bad happening in an application where the software is not operating properly, whatever the vehicle is, it's going to still perform. And safety critical, the definition is really simple. It's if you're running software in a vehicle that there can be loss of life, then you need to have this DO 178 certification. And there's A through D certifications where A is the highest. And security is, okay, I want to do an over-the-air update to a Boeing, 737 MAX 8. And if you don't have DLM trust authenticating the update and signing the update from point A to point B, then you have a malware distribution system on your hands. It's just that simple, right? And Tesla, right, whether it's a Tesla or an airplane, right? Tesla built their own because they're very proud people. They have a lot of not invented here, so they want to build all their own software. Their over-the-air update system was hacked multiple times in the beginning.
Which is why Tesla went to DEF CON and other conferences such as CanSec West to basically try to figure all that out in public. As you said, they built it all themselves and they wanted validation for it. But, in security, there's that old joke about don't roll your own encryption.
Yeah. Yeah. Oh, that is very true. I joke with people all the time. I was like, look, people come to me and say, well, I need the source code for your encryption libraries. I'm like, nah, I don't think you want people messing with our source code. It ships in 100 million devices a year or more. And I doubt anybody could write faster crypto than we've written over the last, 15 years.
So we've talked about automotive and aerospace. Are there other critical infrastructures that also need this kind of security?
So we have customers all across the gambit. So, if you look at the transition that NIST and the government are pushing through, going from, RSA and ECC public key to post-quantum encryption, one of the first verticals that requires it everywhere are network devices. So switches, routers, hubs, load balancers, firewalls. So the government has already come out and said by 2027, you will be post-quantum ready. So what that means is you will move away from any algorithm that is vulnerable or susceptible to a quantum computer hack, which are all the public key algorithms. So RSA and ECC. AES, we're going to simply double the size. That's going to be fine. But we're going to move to something called MLDSA or MLKEM for key encapsulation agreement. There's some other algorithms that are interesting that we're looking at. But that sort of is the first transition. So networking equipment is a big vertical for us. The other verticals that historically, one in particular that has had no regulation is the medical device vertical. So I don't know if it was 2 years ago now, maybe even 3 years, the FDA went from having no teeth to having an incredible amount of teeth, to the point where they could send a letter to a medical device OEM and say, you can't ship this product because it's not secure. So they came out with the omnibus law, and you could look this up. Within that, there's something called Section 524B. Within that, it says you will have encryption at rest, you will have encryption in transit, you will have device authentication, you will have secure over-the-air update. So that's effectively calling out DLM Trust and OmniTrust DLM Update, right? And we solve the whole problem. It's a supply chain issue. It can authenticate every layer of software. The same onion exists in a medical device, right? A defibrillator or an insulin pump. Many of them have, a CPU, secure boot. They may or may not have an operating system. They have an application, and then they have a connection to the outside world because everybody wants to look on their phone and see if their insulin pump is working properly, right? Or they want to, give themselves more insulin through an application. So huge attack surface, huge issue, safety critical, loss of life is there, right? And it's mission critical. So we are seeing a lot of inbound activity there. Some companies believe they've got it solved. Many of them don't. And, I just don't want them to learn the hard way.
So with the FDA guidance, that's for new products. That's for new devices that are coming onto the market, and it's not retroactive.
So let's talk about the last one, CRA, right? Cyber Resiliency Act coming out of the EU. This is retroactive. We've got customers coming to us saying, not only do our new products need to be CRA, our old products need to be CRA.
If you want to know more about the European Union's Cyber Resilience Act, or CRA, check out episode 71 of Error Code, where I talk to Roland Marks at Swissbit for a deep dive.
And what you find on the security side of the standards, as opposed to safety critical, right? The security circle that I talked about earlier, you've got the same elements, right? You've got the onion, you've got hundreds of different CPUs that are doing the security differently, and they all need every layer of the onion to be authentic. Mm-hmm. And CRA calls out the same issues, right? Encryption at rest, encryption in transit, device identities. Is it from a known good source? Can you do over-the-air updates securely, right? Those are the 5 fundamental things that we look for in a standard that say, this rings the bell. This is a vertical we want to focus on. Because, many, I watch, I call them enterprise refugees, right? In the enterprise world, right? I know firewalls don't work because there's 12 firewall companies, right? Now, I'm not saying they're bad companies, but their problem set is very difficult to solve because a firewall is like a cone, right? And you can vary the cone and say, all right, I'm going to open these ports, or I'm going to close it to just one port. And by definition, the network doesn't work if you unplug everything, right? So the usability is useless. So the enterprise has to deal with this pesky thing I call promiscuity, right? Where your PC wants to go out and talk to 50 million websites. Your PC wants to go out and talk to 50 million AI agents, and we'll get to that later, right? But at the end of the day, we picked embedded. 1, it's hard, and 2, at least we know we can solve the problem, meaning we generally know what's running on that embedded device. So if we authenticate everything, we reverse the cone and we say, look, if we didn't sign the software, you're not running on our device. Full stop. And that's why we don't call it PKI. We call it device lifecycle management, because we authenticate the users, the manufacturing sites, the field service sites. We authenticate the devices and all the digital assets on the device. And that's a key, that's a certificate, that's all the payload, all of those layers of software we talked about. We authenticate everything. So it's a very nice solution. It's a hard market. It's a big market. And it's really a mind share issue. And as a company, we've never really stepped out and said, look, we are going to do this. And that's why we picked the name OmniTrust, because it really is end-to-end security trust management. And it's from silicon all the way to an AI agent.
So we'll get to AI in a moment, but I want to pick up on the post-quantum guidance that's coming out. And what I'm hearing is that, there needs to be flexibility built into all that. And so whatever we certify or whatever NIST certifies as being post-quantum secure, that could change.
It's very true. So we call it in the industry, we call it crypto agility. We build that into all our solutions, right? Our back end DLM trust system is already PQC enabled, so we can manage that. We can add algorithms to the back end platform, but we can also add, highly optimized embedded, we call them flex embedded toolkits that we can add to the device side. But there are limitations to that, right? Because as you know, embedded processors aren't enterprise class processors, right? So in some cases, you've got a very small controller in a vehicle, and you're not going to be able to, go from a small post-quantum crypto algorithm to some massive one potentially. So there are limitations. Everyone loves to talk about agility. In some cases it's going to work, in some cases it's not.
So with the advent of AI, we have the IoT world. We're talking about devices talking to devices, or having basically cut the humans out of the equation. I'm wondering if David could talk a little bit about the potential problems that we might be seeing a few years down the line.
It's funny. I was talking to my son, he got a computer science degree. He's entered the workforce. He was working at, one of the AI companies, and he went to another one. But, I was like, Grayson, I'm old now, and I remember the day when there was a dot-com bubble, and I never thought I'd see another inflection point in the industry in my professional career. This is 100 times bigger than that, right? And this is not a bubble, and this is not going away, and there are zero guardrails, right? And it is very, very frightening, right? And it's frightening from multiple vectors. It's frightening from the fact that you're going to remove a human from a mission critical IoT device decision, number one, right? That's obvious, but it's even more fundamental than that, right? And I love the analogy of, most of us that are old enough have watched the Jetsons, right? And it's this futuristic cartoon, and we've all seen the episode where Rosie, the housekeeper, loses her mind and her software goes batty and she starts acting crazy in the house. And I call that a constitution, if you will. Your robot will not kill you, right? You're, or Lost in Space, right? Their robot went crazy, right? But there were certain guardrails that, the big AI companies, the frontier companies, OpenAI, Anthropic, Google, they have to put in place to ensure that that doesn't happen. But I am focused in an area that says, as an enterprise, right, who is my trust provider, right? Again, why did we pick OmniTrust? We picked it because there needs to be Switzerland, right, that governs trust from the silicon to the device to the agentic AI agents that are running across your network. And you need to have the right lens on it, meaning as the enterprise, what does that mean to me? And what are the guardrails do I require? And it's an enterprise question too, right? Because on your laptop, you have a browser that goes everywhere. That is your world now, because everybody has pushed us to the web, right? I can't turn on Outlook without going to the web. I can't use it without being connected ultimately, but I can go to anywhere. And who's going to protect my enterprise as the CEO of my company, right? We're growing leaps and bounds. Where are my employees going, right? How do we know what they're doing? How do we know that my entire world isn't getting sucked into, the black hole of AI, and all of my intellectual property is gone instantly? So it's really a multi-layered problem. And on the enterprise side, it's scary. We're going to start on this agentic AI that runs on devices, but OmniTrust is everywhere it matters, and we mean it.
So David's company is already working on trust issues with the AI platforms and how agentic tools are being used on those platforms.
Most of what you're hearing today is we're going to treat an agent as an identity, and we're going to have unique attributes, right? If it's a human, I know you, Robert, because you've got blue eyes, you've got gray hair, you're Caucasian, right? I know you, right? And I know your voice now, right? Where agents are going to have similar attributes, so we're going to have to develop the histogram on what that means and tie it to a trust, digital asset, whatever that might be.
Okay, that's actually kind of cool how one can fingerprint agentic AI. And if someone's pretending to be that agentic AI, you could potentially flag it and say, no, they don't have all the right attributes.
Yeah, our message at RSA, we're going to have a lot of messages. It's a big story. I think fundamentally, the key message that we're going to be giving on the enterprise side, right? Not the DLM side, but the certificate lifecycle management side, is there's way more than certificate lifecycle management. So there's companies like Venafi that got bought by CyberArk. There's companies like Keyfactor that are owned by a PE, but they're independent. There's companies like AppViewX. Those are the three players in the marketplace. They've made a good living off of certificate lifecycle management, which means that switch, router, hub, firewall, load balancer all have a certificate, and we're managing those for you. We're counting that, they're each 1-year certificates, and you need to change them out automatically, right? It's a pretty well-known space. It's sort of obvious from our perspective, but we're taking it one step further, right? CLM is not enough, right? CLM, if you're talking CLM, you're behind the curve, right? So, we have our own OmniTrust magic quadrant, if you will, and we call it ILM, Identity Lifecycle Management. And underneath ILM, you're still going to have certificate lifecycle management, but you're going to have secrets. You're going to have, cryptographic keys. Any cryptographic function, any digital trust asset will be managed by identity lifecycle management. So CLM is dead. ILM is the future. We're bringing it out at RSA. That's really the story. And the reason I explain it that way is because let's just take passwords. When you look at all the major hacks recently, right? F5 got hacked. They lost their source code. Years ago, SolarWinds got hacked. What was hacked? If the windows and the doors in your house have wonderful locks, people are going to try and steal your keys, right? So what's happening is people are finding very unique ways through social engineering or through brute force attacks to get your credentials, your keys effectively. And that's effectively what's happening. So you've got passwords, right? If you're a developer at some enterprise company, you've got 25 apps and they all have your passwords for you to use them. Secrets, passwords are 10, 20, 50 times bigger than the certificates on all those devices across your network. So we are basically buying in and saying, look, we're on the case. OmniTrust everywhere where it matters. So we're going to manage your passwords as if they're certificates.
I'd like to thank my guest, David Sequino, for coming on the show and talking about trust issues in the supply chain. It's critical with infrastructure that we know exactly where the parts and the software come from before they're put into critical devices. Hey, if you're enjoying Error Code, tell a friend. I'm sure there are other people out there who like narrative information security podcasts. And I'd really like to hear from you. Go to errorcodepodcast.com to get more details. And tell me what you like, and even what you don't. I've got some great episodes coming up. We'll have more on Volt Typhoon, Salt Typhoon, and hacking utilities supply chains. Subscribe today. I don't want you to miss out.